Hi everyone. Today we're going to discuss something interesting again. In fact, it is something that has fascinated me for quite a long time now. And we're going to specifically talk about TON 618. It does represent one of the most extreme examples of how space-time can behave in our universe. And rather than thinking of it as something frightening, I like to think of it as one of the most rather elegant and powerful structures that nature can create. So TON 618 is what astronomers call a supermassive black hole. And in fact, it is one of the most massive black holes that we currently know about. It is located roughly 10 billion light years away from Earth and far away from our galaxy. And even though it is so distant, astronomers are still able to observe it because of something remarkable happening around it. TON 618 is what is known as quasar. And a quasar is an incredibly luminous region created when matter spirals into a supermassive black hole. And as gas and dust fall inward, they form a rotating structure called an accretion disk. So the material in this disk becomes extremely hot and energetic, and it is releasing an enormous amount of light. And in fact, quasars can shine so brightly that they can potentially outshine entire galaxies. So the black hole itself is invisible, but the energy released by the surrounding material allows us to detect it from across the observable universe. What makes TON 618 especially extraordinary is its mass. Current estimates suggest that it contains around 66 billion times the mass of our Sun. And to give that a sense of scale, the event horizon of a black hole grows larger as the mass does increase. So from an object as massive as TON 618, the region where gravity dominates spacetime becomes truly immense. If we imagined TON 618 where Sun is today, the boundary where light itself can no longer escape would extend far beyond the orbit of the outer planets. So this gives us a glimpse of just how enormous that structure really is. But beyond its size, what I find most fascinating is the geometry of space-time around it. And in fact, according to Einstein's theory of general relativity, massive objects curve space-time. In a black hole represents the most extreme version of this curvature. So near TON 618, space-time is shaped in ways that stretch our imagination. Time slows down relative to distant observers, light bends along curved paths, and the structure of space itself follows the gravitational geometry of the black hole. These effects are not chaotic or mysterious in the sense of being random. They are precise consequences of the equations of general relativity. And in that sense, black holes are not merely cosmic oddities. They are incredibly elegant solutions to the laws that govern our universe. When I think of TON 618, I like to imagine approaching it like from far away in space. So at first you would see a brilliant region of light surrounding the black hole, the glowing accretion disk created by infalling matter. The disk would appear bright and energetic, forming a rotating structure around the dark central region. And closer in, gravity bends the paths of light itself. Photons from the accretion disk can curve around the black hole and produce a striking visual effect known as gravitational lensing. The result would be a warped and beautiful view of light circling around the curved geometry of space-time. And at the center of all this activity lies the event horizon. The event horizon is not a surface or a wall. It is rather a boundary in space-time that marks the region where all future paths lead inward. So crossing it would be not involve hitting anything physical. Instead, it represents a change in the causal structure of space-time. For example, moving inward, the crossing would happen smoothly in their own proper time. But for distant observers, however, the approach would appear slower and slower because of gravitational time dilation. So light from the traveler would become increasingly redshifted as it climbs out of the deep gravitational well. Black holes like TON 618 allow us to explore these ideas not just as mathematics, but as real structures that exist in our universe. They remind us that space-time is dynamic, flexible, and capable of forming structures far beyond everyday examples and experiences. For me, TON 618 is not just an extreme object, it is a reminder of how vast and creative the cosmos truly is. The universe contains structures of incredible scale and elegance, and black holes are among the most remarkable examples of this. So thank you for joining me tonight on the journey with TON 618. And for me, again, this is one of the most extraordinary regions of space-time as we know it so far. So as always, stay curious about the universe. Thank you for listening and take care.